All right, here we go. Last one for the week is homework 3-3. And a few different types of problems here. On this one, they have given you this data. They've put it in a scatter plot for you, and they have actually created the line of best fit. I didn't copy the line of best fit, but let's just say it's something like this. It's got a negative slope, so let's just say that's the line they give you, so we can use it in this problem. But again, in the problem, they're going to give you that. You've got to answer some questions. So first thing it says, for this data, female life expectancies that are greater than the mean, greater than the center of the female life expectancies, tend to be paired with birth rates that are they greater than the mean, or are they going to be less than the mean is really what we're looking for here, okay? So since this is a negative correlation, because of the way this, I got a negative slope here, as the life expectancies are greater, so here's the life expectancies go up, then the birth rates are coming down, okay? Because there's a negative correlation. So I'd be looking for less than the mean as the thing I'd be choosing here. And then this other equation, the other question is, according to the regression equation, for an increase of one birth in the birth rate, or one in the birth rate, there's a corresponding decrease of how many years. So when we're talking about this rate of change here, we're going to look at our equation that they've given us and look for the slope, okay? So that's telling us how the rate is changing. So in our case, we've got, as you go up 1 here, you're coming down 2. Okay, so you'd have a decrease of 2 because the slope is -2. All right, have fun with that one. What's next? This next one, we talk about residuals. Okay, so again, if you see this picture here, they've drawn the line of best fit. They've plotted these points. They've drawn the line of best fit. And notice this line of best fit does not go through any of these points over here, okay? And so this distance from each point to the line of best fit, this little distance right here, are called residual values. And what you're going to be doing in this problem is finding the residuals for certain points. So in this first one, let me get rid of those real quick. So in this first one, I'm looking at when time spent texting is 4. So think about that. Here's 4. Here's the point we're looking at right now. Okay? Notice its corresponding y value is 4.5. Okay, so I can get that from looking right here. Okay, but the time spent exercising, the observed one, is 4.5. Now, to get this time predicting, the predicted time spent exercising, I'm going to have to use the line of best fit equation and plug that 4 into that equation. And get a value, okay? I'll do that real quick. Maybe I can get my calculator working here. I think that's going to come out to 5.48. Okay, which if I look at my picture, here's 4, come up to the line, that point on the line is my predicted value. If I go over, that looks to be, really close to 5.5, so 5.48. The residual value is going to be the observed value minus the predicted, okay? So in this case, I would get a negative 0.98. And that residual is negative, and I can predict that it's going to be negative because my observed value is below it. In the next one I do, when I go to x is 6, here's the point I'm picking out. It's got a observed value of 5.5, but when I plug it into when I plug that 6 in up here, I'm going to get this value right here. And when I take the difference there, this is going to give me a positive number. Okay, so you're just finding the residuals there. All right. So again, residuals, this is just the distance between the observed value and the predicted value. And predicted value is going to come from the line of best fit. All right, got to go all the way back to Algebra 1 and come up with a line of best fit and come up with the equation for it. So remember, slope, y-intercept, and when you come up with your line of best fit, it can be different. So I'm gonna say this is my line of best fit. Somewhere in there, I'm gonna make it, yeah, that's my line of best fit. So, and I picked this point because, boom, I'm going to go right through, my y-intercept is 9. So right away, I know I got a 9 there, and then I just got to find my slope. So let's say this point right here, I go from this point to this point, I'd go up 1, 2, 3, 4, and over, back 1, 2, 3, 4, 5. So I'm going back 5. So I would have a slope of negative 4/5. So I'm going to have my line of best fit. Now you might get something different, but as long as it's close to that, they're going to give you credit for it. Okay? All right, so have fun with those, and you'll be through with the week. So got a long weekend ahead of us.